Hello and welcome to the fifth and final video on our series on fiscal policy. In this video, we're going to think about a slightly different type of model that we can still cast in the same shape of the model we've been working with. This is going to be a Keynesian model. And so some history. The model we've been using so far is based on neoclassical macroeconomics. You've read a little bit of that in the reading for the first module. The key in that model is that it takes into account how consumers solve an intertemporal problem and incorporate equilibrium conditions in the economy, like for example, the government's budget. Now, that is something that not all models take into account, and we're gonna see as the video progresses why we wouldn't wanna always take into account those things. Now, the models I'm gonna be referring to now, like Keynesian models, have been widely used in economics for very many years, and they are very popular, especially in policy circles. So here I'm thinking about basic Keynesian models as the ISLM, but also fancier Keynesian models that incorporate the same logic of the model I'm about to show you. I am going to focus on the IS portion that stands for investment savings, but it's really a fancy or complicated way of just saying I'm going to be focusing on the aggregate demand of the model. The question is, what is the effect of government spending in a Keynesian economy? So the first thing is to think about how the models are different. And so the consumers in the Keynesian model do not maximize utility subject to budget constraints. Instead, we're going to have them follow a consumption rule. So we're going to say that consumption in the aggregate for an economy tends to be some multiple of present disposable income. And this is important in many respects. The first one is we're saying that consumption depends on Y and depends on T, on taxes, same as we were saying it before, just now we're making it depend on a very specific way. You depend on present disposable income, not on the present value of your lifetime income, not on the present value of lifetime taxes. So here, whatever happens to taxes in the future is not going to affect us directly. Now, because we're going to be consuming a fraction of disposable income, that fraction, it's exactly the MPC. That fraction, the marginal propensity to consume, it's telling us directly how for every dollar of disposable income, the consumer wants to consume theta cents. So that the name of this Greek letter is theta, okay? Now theta is going to be fixed, and so the consumer is always going to consume or save the same fraction. In the model we had before, the marginal propensity to consume could vary depending on how much income there is. If there is more income, perhaps the marginal propensity to consume is lower. You don't want to consume as much, you might want to save more. If income is lower, then perhaps you want to have a higher marginal propensity to consume. You want to consume all that income because you're relatively poor. Here, theta is going to be constant. And another important bit, consumption is not going to depend on the interest rate. So we can already see where that's going. There are going to be some crowding out effects that are going to be absent from this model. Okay. Next, the equilibrium, well, it's going to be demand determined. Firms are going to supply as much output as is demanded. Government has to balance the budget, but we're going to see that doesn't have as much bite. And we're going to focus on aggregate demand, or what's often also called aggregate expenditure. And so aggregate expenditure is going to be equal to total consumption plus total investment plus total government spending, just as before. Again, aggregate demand or aggregate expenditure, these are the same concept. I just want to introduce this new notation to tell these two apart, the aggregate demand we had in our previous model from aggregate expenditure here. Now in equilibrium, of course, aggregate expenditure is equal to aggregate demand, it's equal to total output. And we can represent this with something called a Keynesian cross, a graph that you should recognize from our previous model in the way we were defining the aggregate demand. So here is the Keynesian cross. What we have here is income on one axis, planned expenditure on the other axis. So this is E equal to consumption plus investment plus government spending. Notice that this is a straight line because consumption, it's linear in disposable income. And so the slope of this line is going to be exactly theta, okay? Once we see that representation, and just to make it clear that we understand what's going on, This line is how much you wanna, what your expenditure will be at any level of income. The dotted blue line is the points at which expenditure is exactly equal to realized income Y. So that is the equilibrium point. That is the aggregate demand. So what you want is the point in the middle that's going to tell you what aggregate demand is at some given level R1. If you change the interest rate, that's going to change investment moving up or down the expenditure line. As the expenditure lines moves up or down, you're going to cross at different points the blue line. And those points are going to give you how the aggregate demand is going to move with the interest rate. Okay, increasing government spending, that's changing G. Holding taxes fixed. So we're going to hold current taxes fixed and increase government spending. That's going to increase total expenditure. And thus, it's going to increase income right away, one for one. I'm sorry to be going back and forth. I just want to make sure that you see it. Government expenditure affects expenditures one for one. Okay, so we have this first effect. Then there is a second effect because consumption is going to go up by the MPC. Because when I change government expenditure, I change expenditures, I change income, and because I change income, I change consumption. But because I change consumption, I'm gonna change government expenditure, I'm just gonna change total expenditure again. So there is an additional second round increase in income. And because there is a second round increase in income, there's gonna be a second round increase in consumption, which is gonna have a second round increase in income, which is gonna then have another round of increasing consumption. And this is gonna keep going again and again and again, increasing income, increasing consumption. That is the Keynesian multiplier. And so the basic notion that you can have large effects on output because of changes in government expenditure comes from this loop, from this way of thinking, that an initial increase in government spending that is not accompanied by increases in taxes is going to increase expenditure, increase income, which is going to increase consumption, which is going to increase expenditure, which is going to increase income, which is going to increase consumption. That is the multiplier effect. And so that's what we see in this equation here. Again, the first line, just as before, is just the changes: change in output, change in consumption, change in investment, change in government spending. Change in investment is zero because interest rates are not changing in this example. Then the change in consumption is going to be theta times the change in disposable income. But as we said, there is no change in taxes. And so what we get here when we solve is that the change in output is going to be proportional to the change in government spending. But here is the trick. The multiplier is going to be 1 over 1 minus theta, or 1 over 1 minus the MPC. Because the MPC is less than 1, but it's positive, this is a number greater than 1. Not only it's a number greater than 1, we also know that the higher that number is, the higher MPCs are, the higher this multiplier will become. And that should make a lot of sense. Because this multiplier effect of more consumption, it's going to be stronger the more consumption reacts. If you had this to be 0, then you will just get change in Y equal to change in G, just as before. Before, the change in consumption was 0 because the effect of additional government spending cancel with the effect of additional taxes. Now that it doesn't, you get this multiplier effect that's going to be stronger the more consumption reacts to that additional income that you're getting. So what are we missing? Why is this model giving me such a large multiplier that depends on the consumption behavior, while the other one is giving me a multiplier of 1? Well, our baseline model was missing a bunch of features. We discussed them. But the simple Keynesian model is also missing many features, and some of them are actually already in the model we had before. So consumers do not optimize, they instead follow a fixed consumption rule. That's going to have effects for us, particularly because of the forward-looking part. in this economy, we're acting as if all the agents were borrowing constrained. If all the agents only care about present consumption and present income, and they weren't thinking forward about what's going to happen in the future. Now, the reality is neither the previous model where everybody was thinking forward, nor this model where everybody is just living in the present. We briefly talked about models with heterogeneous agents in the introduction to the course. These models are making a lot of effort in recognizing that some agents are well approximated by having very high MPCs and depending mostly on how income behaves today. While other agents have lower MPCs and they might be less constrained and more forward-looking. In this model, taxes do not adjust when G changes, and that might be a good way of thinking in the very short run. When, if you're in the middle of a recession, you might change government spending and leave your tax reforms for 2 or 3 years into the future when the crisis has passed. But it is not always a good way of thinking about it, because if you think that taxes are going to adjust soon, then again, we run into the forward-looking part of the model, where agents should be taking that into account. So is one model better than the other? Well, both models are wrong in many ways, but they both teach us what matters. If you have these conditions in your model, what's going to be your multiplier? If you have these other conditions in your model, is your multiplier going to be higher or lower? So the models helps us to learn by seeing the differences between them and then the differences in the implications they have. With that, we finished this set of videos on fiscal policy. In the next set of videos for this second module, we're going to be covering the effect of aggregate demand shocks on the economy, on local consumption. I hope you enjoyed them.